Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in this video we will study the pin description or the pin diagram of 8051 microcontroller. So let us start with our topic. The 8051 microcontroller, it is one of the most popular general purpose microcontroller, and it is an 8-bit microcontroller which is available in a 40-pin DIP IC. So 8051, it is an 8-bit microcontroller, means that all the operations of the 8051, they are limited to 8 bits. Means it cannot perform operations which are greater than 8 bits, or also we can say that it deals with the data which is of 8 bit. Okay, more than 8 bit data it cannot handle. And also it is available as the 40-pin DIP dual inline package, means this 8051 IC, it has 40 pins, and these pins, they will have different functions. So in this video we are going to study the pin diagram of 8051, how these 40 pins, they are assigned different functions. So coming to the pin diagram, this is the pin diagram of 8051 microcontroller. You can see that this IC, it is having 40 pins, one from 20 on other one side and 21 to 40 on the other side. Now all these pins, they have different functions, like pin number 1 to pin number 8, they are for port 1. Out of these 40 pins, there are 32 input-output pins which are divided into 4 ports. Okay, that is port 0, port 1, port 2 and port 3. Now each port, it is of 8 bits. So you can see that port 0 is having the 8 bits from 0 to 7. Port 1 is also having 8 bits from 0 to 7. Port 2 is also having 8 bits from 0 to 7, and port 3 is also having the 8 bits. So 8-bit ports are there, and there are 4 ports. So we can say that we have port 0, port 1, port 2 and port 3. So out of 40 pins, we have 32 pins for these ports. Now these pins, they can act as the port pins also, and there are different functions, other functions are also there. So at one time they are acting as the port pins, and other time they are acting as the different pins. Like for port 0, you can see that these 8 pins, they are assigned for the port 0 also, and for the lower order address bus and data bus also. Address and data bus, in the case of 8051, we have 16-bit address bus and 8-bit data bus. So 16-bit address bus is from A0 to A15. Okay. A0 to A15, it is divided into 8 bits, that is A0 to A7, it is the lower order address bus, and A8 to A15, it is the higher order address bus. So lower order address bus A0 to A7, it is multiplexed with the data bus. Data bus is also 8-bit. So it has become AD0 to AD7, means both as address and data bus. Okay. So these port lines, they are acting as the port bits also and as the lower order address and the data bus also. Similarly, for port 2, we have the port pins also and also the higher order address bus. Port 1, it is not multifunction, it is assigned for port only. Port 3 pins, you can see that it has acting as port pits also and as different signals also, like received, transmit, and interrupts signals are also there. For timers also it is there, and for read and write signals also. So it is used for external signals also. Then we have pin number 9 for the reset. Pin number 18 and 19 are for the crystal. Pin number 20, it is for the ground, and pin number 40, it is for the 5-volt power supply. So 40 and 20, these are for the power supply connections. Remaining we have our pin number 29, 30 and 31. 29, it is for PSEN, that is program status enable. Then 30 is for ALE, and 31 it is for EA. So let us study the description of all these pins, that what are the functions performed by these pins, what operations they perform. So let us study this pin diagram in detail. First, we will start with the port pins, that is port 0 to port 3. For port 0, we have the pins from 32 to 39. Okay, it is an 8-bit port. So port 0, it is used as a general purpose 8-bit input output port, and it is used as a port pins only when no external memory is present. In microcontrollers, we have the external memory. So this memory, it has to be addressed by the microcontroller. So for addressing, we use the address bus. Now address bus in case of microcontroller, it is of 16 bits. So the 16 bits, out of these 16 bits, 8 bits are multiplexed with the data bus. So the multiplexed address and the data bus, it is used for addressing the external memory. So if no external memory is present, then these pins, pin number 32 to 39, they are used as the 8-bit port. And when external memory is present, then it is used as the multiplexed address and data bus, which is used for addressing the external memory. That is why in the pin diagram, it is shown as both the addressed and the multiplexed address and data bus, and also the port pins. So when no external memory is present, it will act as P0 to P, means for P0 is for the port 0, and it is the bit number 0 to bit number 7. It is having 8 bits here. So these 8 bits are assigned like this. For port 0, we have P0, and dot 0 and dot 7 means these are the bits, and when it is external memory is present, then it is acting as multiplexed address and data bus, so it will act as AD0 to AD7. That is multiplexed lower order address bus and the data bus. Next we have is port number 1, because there are 4 ports, so port number 1 pins are from pins 1 to 8. In the pin diagram you can see this is the port 1, from pin number 1 to pin number 8 we have, and these pins, there are 8-bit pin, 8-bit port is there. These are the bits 0, 1, 2, 3, and P1 is for port 1. So its bits will be P1.0 to P1.7. Okay. So port 1, it is also an bidirectional input-output port having 8 bits, and it is used for variety of interfacing tasks. Whenever microcontroller it is interfaced with the peripheral devices or any other IC, then we can use the port 1. Now all other ports, because it is having 4 ports, so port 0, port 2 and port 3, these ports they have dual roles, means they can be used as input output port also and as other pin signals also. But this port 1, it is not having any dual roles, it is having only the single function, that is of as an bidirectional input output port. That is why you can see in the pin diagram that every port 0, port 2, port 3, they are having dual functions. It is port pins also and other pins functions are also there, but for port 1 there is only a single function. So here I have written that other ports they have dual roles, but this port doesn't have any other functions. Okay. Next port we have is port 2. Port 2 pins are from pins 21 to 28, and it is also an 8-bit port, so its bits will be P2 is for port 2, bit number 0 to bit number 7. Okay, 8-bit port is there. Now this will act as the general purpose 8-bit port only when the external memory is not present. When external memory is present, it will act as the higher order address bus. So both port 0 and port 2, they act as the address bus also and as the port pins also. Next we have is port number 3. Port number 3 pins are from pins 10 to 17. 8 pins are there. So P3.0 to P3.7. Again, it can be used as an 8-bit port. So this port is also an 8-bit port. It will act as normal input output port also, but it has additional functions also, like serial transmit and receive. Two external interrupt pins are there, two external counter inputs are there, read and write pins for the memory access. So for serial transmit and receive, it has RxD and TxD. For two external interrupt pins, it has INT0 and INT1. Two counter and timer inputs are T0 and T1. And the memory read and write, it has write signal and read signal. So whenever the microcontroller it want to use these signals, it can use the 8 pins of the port 3. So these pins are used for the serial transmission, that is for serial communication, transmit and receive. RxD is for receiving the data and TxD is for transmitting the data. Then for interrupts, we have the two interrupts, that is INT0 and INT1. For two timers and counters, we have two T0 and T1. And for read and write pins for memory access, we have write signal WR and read signal RD. Okay, so this was the 4 ports of the 8051. So next pins we have is in the pin diagram. We have studied about pin number 1 to pin number 8. Next pin we have is pin number 9. So pin number 9 is assigned the RST, that is the reset. Now this pin is used to reset the internal registers of the microcontroller. When this pin is high, means all the internal registers, status registers, flag register, all the registers, they will be cleared. Okay, means they will come to their initial conditions, that is the starting condition 000. So whenever this signal is high, it will reset the microcontroller's internal registers and ports upon starting up. Now this pin, it has to be held high for 2 machine cycles. So whenever we want to reset the microcontroller, we have to give this signal high to the microcontroller, but it should be high for 2 machine cycles, otherwise it will not be acknowledged by the microcontroller. Next, pin number 10 to 17, we have already studied that these are assigned for the port 3 also, and other functions are also associated with it. Then we have pin number 18 and 19. 18 and 19, these are assigned for the crystal. The crystal is directly connected to the 8051 IC, and that crystal will provide the clock frequency or the clock cycles to the internal operations of 8051. Like if you want timing and control signals, all will be provided with this crystal clock frequency. So pin 18 and 19. Crystal pins, that is Xtel 1 and Xtel 2. These are for the crystal. So the crystal, because in case of 8051 it has a built-in oscillator amplifier, so we need only to connect the crystal to these two pins, that is pin 18 and 19. Crystal is directly connected to these pins, and that built-in oscillator amplifier, it will generate the clock pulses, and these clock pulses will be provided to the internal circuit of 8051. Okay. Next, pin number 20. Pin number 20 is for the ground connection, and pin number 40, it is for the plus 5 volt power connection. So pin number 20 and 40, these are for the power supply pins. So 8051 chip, it needs plus 5 volt and 500 milliampere of power supply to function properly. But there are also the lower power version also, which uses the less power than this plus 5 volts. Okay, so plus 5 volt will be connected at pin number 40, and the ground is connected at pin number 20. Now next, pin number 21 to 28, we have already studied that these are for port 2. Then we come to port pin number 29, 30 and 31. Now pin number 29, it is assigned PSEN. Okay, that is program store enable. Now as in 8051, we have the external memory, and this memory is divided into two parts, program memory and data memory. Program memory is used to store the user programs, and data memory, it is used to store the data. Now if we want to access the external memory, then we use the signal PSE, that is program store enable. So this signal, it is used to read the data from the external program memory. Whatever signals or whatever status is stored there in the program memory, whatever information is there, if we want to read that information, then we can use this signal. Now as this signal, it is an active low signal, it is having a bar over it. You can see it in the pin diagram. We have a bar over it, a line over PSEN. So this line indicates that this signal, it is an active low signal. It will be active when its value is 0. Okay, that means if we provide low voltage on this pin, then only it will perform its function. So in order to use the external memory, it is required to provide the low voltage, means 0, at both PSEN and EA pins. Okay, so we are using this pin number 29 to read the signals from the external program memory. Then we have pin number 30. So pin number 30, it is assigned the function ALE, that is address latch enable. Now as we have studied that the address and the data bus, they are multiplexed with each other, means same 8 lines, they are functioning as the 8 address bus also and as the data bus also. Now when it will act as it will be decided by the address latch enable. So address latch enable, it is used to demultiplex the address and the data bus. Okay, so when this latch is enabled, it means that the 8 lines, they are acting as the address bus. When this latch is disabled, it means that the 8 lines, they are acting as the data bus. Okay, so if we want to demultiplex, we will use this pin number 30. Okay, so when this signal is active, it means address is available there. So if suppose multiple memory chips are connected to the microcontroller, this is the microcontroller and we have different memory chips, and each memory chip, it will have the signal ALE. Okay, now whenever if microcontroller it wants to communicate with this memory chip, it will activate the signal ALE. So address will be there on this address latch on the address bus, and that address will be the address of the memory chip. So if we want to select any one of the chip in case of multiple chips, then we can also use this address latch enable. Whichever memory chip we want to select, we will activate the ALE signal for that memory chip. Okay, and also it is used to demultiplex the address and the data bus. Next pin we have is pin number 31. Pin number 31, it is EA bar and VPP. So this pin number 31, it is used to enable or disable the external memory interfacing. External memory is present outside the microcontroller chip. Okay, it is embedded on the same chip, but it is outside the microcontroller. So if the microcontroller it wants to communicate with the memory, interfacing is to be used. So it is this pin EA, it is used to enable or disable the external memory interfacing, and because it is having a bar over it, so it will be active when its value is low. So it should be connected to ground to indicate the presence of external memory. When the signal is low, it means that external memory is connected, it is enabled, and now the microcontroller it is communicating with that external memory. Now next pin number 32 to 39, we have already studied that this is for port 0, and also it is acting as the multiplex address and data bus. So these are the all 40 pins. We have studied the description of all the 40 pins, that how these pins are used for different functions. Okay, so I hope that now this topic is clear to you. Thank you.